You. Today we are going to look at Theorem 3, which will focus more on how to solve this particular problem. I'm not going to solve the problem really, but what I am going to do, I will try by all means that I'll help you to find the thing, because the thing is here, the exponent is 5. If it was less than 5, we could be solving it. So today we are doing theorem 3, which is multiplication by t. This is theorem 3. What does theorem 3 state? It states that if f of s is equals to the Laplace transform of f t, and n is the element of all positive integers, therefore the Laplace transform of t to the power n, f of t, is equals to -1 all to the power n times d to the power n all over dsn in bracket f of s, like that. So we need to prove this, and the way that we are going to prove this, we are going to use this part to prove it. Now the proof will be -1 all to the power n d to the power n over ds to the power n f of s is equals to what? The way that you are going to prove this, we are going to prove it using only this part, because it's going to confuse you if we include this part. So we're just going to use that part. So how would you prove it? We are going to say d to the power n over ds to the power n integral from 0 to infinity of e to the power negative st f of t dt. Now, it seems like you are stuck here and there is nothing that you can do. Really, you can do something here. Now, we are going to look at something called the Feynman's trick. It is differentiation under integration. But this one is quite easy. What we are going to do here, we are going to say an integral from 0 to infinity. Now, because this function here that you see here, it is multivariable and we are deriving in terms of s. When we take this differential, when you take the differential and put it inside, it's going to change from the straight derivative to a partial derivative. So we are going to have now the partial derivative to the power n all over the partial derivative to the power n of e to the power negative st f of t dt, like that. Now, if you look at this partial derivative, it derives this entire thing in terms of what? In terms of s. So because this thing is deriving in terms of s, it means that this f of t and that t there are what? Are constant. So by doing a little thing here, so put d to the power n over dsn of e to the power negative s of f of t. If we derive this, we are going to have first negative t e to the power negative s f of t. If we derive this again, what we're going to do, we are going to have what? We are going to have t squared e to the power negative s f of t. If we derive this again, we are going to have what? Negative t cubed e to the power negative st f of t. What can you notice about this? You can really notice that the signs alternate. Now, how would they alternate? When the power of n is even, the sign which is behind the t, it is positive. And then when the power of n is odd, the sign here, it is negative. So we can conclude that when you derive this to infinite, when you derive this until to find nth, we are going to have an integral from 0 to infinite of 1 to the power n, t to the power n, e to the power negative st, f of t dt. We are going to take this n to the power negative 1 outside, which is negative 1, all to the power n, integral from 0 to infinite of negative 1 to the power n, sorry, not negative 1 to the power n, t to the power n, e to the power negative st, f of t dt. Now when you write this to infinite, you're going to have t to the power n in bracket, negative st, f of t dt. You can clearly see that you're integrating this thing in terms of Nantuzan to the power n. So this is the Laplace transform of t to the power n of f of t dt. So this is the proof of this above theorem. Now, how does it work really? Because this is only a proof. Now, how does it work? Now, we are going to do an example here. So the first one, find the Laplace transform of t times e to the power negative 3t. Now, let us use something called here the first shift. How will the first shift operate here? We first need to derive the t, right? We first need to find the Laplace transform of t. So what is the Laplace transform of t? The Laplace transform of t is just 1 over s squared. And then the first shift says, since this t is multiplied by the e to the power of a particular exponent, where there is n, I'm going to subtract negative 3. So I'm going to have 1 over s plus 3 all squared. So this is your final answer by using the first shift. Now, how would you find the same Laplace transform using the theorem? Then the multiplication by t state. The multiplication by t state, I want you to look at this. It states that when you take the Laplace transform of t to the power n times f of t, the Laplace transform of this, it is n to the power minus 1, d to the power n over ds to the power n in bracket f of s, right? What you need to understand is that this f of t here will give rise to that f of s. So what you need to understand here when doing the multiplication by t is that you first need to find the Laplace transform of something that is multiplying t. That is the key thing here. You first need to find the Laplace transform of something that is multiplying t. And after you find the Laplace transform of something that is multiplying t, you are going to substitute them to this equation and then derive. That is the rule here. Find the Laplace transform of the something that is multiplying t, and after I find the Laplace transform that is multiplying t, you need to put it in this equation that you see here and then derive. So let us look at this example here. We will conclude that the answers are the same. So the Laplace transform of t to the power n of t times e to the power negative 3. Now, how can we integrate? How can we calculate this? To do it, we first need to find the Laplace transform of e to the power negative 3t. What is the Laplace transform of e to the power negative 3t? It is 1 over s plus 3. Now we have found the Laplace transform of something that is multiplying what? T. What is the next thing that you need to do? We need to substitute this answer to this equation and derive. So by doing that, you are going to have what? -1 all to the power what? All to the power 1. Why are we saying it's all to the power 1? Because this n that you see here, it is the exponent of t. The exponent of t here is 1, so it's going to be d over ds in bracket 1 over s plus 3, like that. And now, to derive this, we need to derive this. To derive this, we need to use something called the quotient. I don't know how to write it. The quotient rule. Now, how did we perform the quotient rule? But I'm just going to show you here. D over dx in bracket f over g. To derive this, we said it's f prime times g minus f times g prime divided by g all squared. So this is the quotient rule. This is the quotient rule. So we need to apply the same principle here to get the Laplace transform of t times e to the power -3. So I'm going to have here -1 times, what's the derivative of 1? That is 0 times s plus 3 minus 1. What is the derivative of s plus 3? It is 1. All divided by s plus 3 all squared. Right? All squared. Now, by simplifying this, I'm going to have -1 in bracket, -1 divided by s plus 3 all squared. By saying -1 times -1, I'm going to have 1 over s plus 3 all squared. So, you can clearly see that when we are doing the first shift theorem, there is more work to do. Now, the key thing that I need to show you here is that whenever you see something that has an E and a T, always use the first shift theorem. Always use the first shift theorem. The multiplication by t is quite hard because some of you will forget to use the quotient rule here. So it's going to be hard as we move on, but let us look at another example. Another example that we're going to include, it's going to be the nice one. A nice one, by the way. It's going to be the Laplace transform. I'm just going to do E for now. The Laplace transform of t squared e to the power 4t. By doing the first shift, you'll get it's 2 over s minus 4 all squared. The answer here comes from the first shift theorem. So how can you do the calculations here? So by doing, let's say what we are going to do first, we are going to take the Laplace transform of something that is doing t. So that is multiplying t. So I'm going to have e to the power 4t. So what is the Laplace transform of this? This is going to be 1 over s minus 4. Now we are doing here the multiplication by t. So now we are doing the multiplication by t. So what is the next thing that we need to do? Now we have taken the Laplace transform of something that is multiplying by t. So we need to put it where? We need to remember this formula that the Laplace transform of t to the power n f of t. I'm just going to keep writing this formula to remind you because you are not going to be given in a major. So it's -1 to the power n d to the power n over ds to the power n of f of s. Just remember that f of s, it is that function. We are going to include that function. So what we are going to have now, we are going to have -1 all squared. Remember that the exponent of n is 2 now. The exponent of n is 2 now, so it's going to be -1 all squared. D squared over ds squared in bracket 1 over s minus 4, like that. Now, what does it mean to have d squared over dx squared? Now, I'm just going to give an example here. If you have d over ds in bracket d squared f of s here. The meaning of this is just d over ds in bracket d over ds in bracket f of s. Like that. So the meaning of this square, you need to break it into two. So how can we calculate this now? We are going to say it's 1 because negative 1 all squared is 1. So I'm going to have now d over ds in bracket d over ds in bracket 1 over s minus 4. So first we need to derive the inside. How can we derive the inside? We need to remember the quotient rule. When you are writing down there, just remember the quotient rule. So how can we derive that? So we are going to have now d over ds in bracket. This is going to be 1. It's going to be 0 times 1 times s minus 4 minus 1 times 1 divided by s minus 4 all squared. So it's just d over ds in bracket negative 1 over s minus 4 all squared. Now we need to derive this again. Now by deriving this again, we need to use, because now we have squared this, we need to simplify that bracket aside. So let us do that. S minus 4 all squared is what? Is s squared minus 8s plus 16. So this is the bracket when you simplify it. So when you derive this once more, I'm going to have 0 times s minus 4 all squared plus 1 in bracket. Remember, the quotient rule states that if you have d over ds f of g, I'm going to have f prime times g minus f times g prime divided by g all squared. So I am going to derive your denominator. What is the derivative of the denominator there? The derivative of the denominator, you must not derive the bracket, but you must derive what is simplified. So what is the derivative of x squared, of s squared minus 8x plus 16? That is just 2s minus 8. And then divide this by s minus 4 squared and all squared again. And all squared again. So you're going to square it again. So by doing that, if you simplify this, I am going to have 2 in bracket s minus 4 all divided by what? By s minus 4 all to the power 4. But if you simplify this further, I'm just going to have 2 over s minus 4 all cubed. So this will be your final answer. You can just look at at this point there. So these are just an examples problems which are quite easy. Now let us just increase the strength of this thing. So by increasing the strength, what do I mean by this? I mean that what will be the Laplace transform of t squared of sine for t? What is the Laplace transform of that? So the first thing that we need to do, we need to find the Laplace transform of sine for t. The Laplace transform of sine for t is what? It is 4 all divided by s squared minus 16. That is the Laplace transform of sine. What is the next thing that we need to do? We need to remember a particular formula here, that the Laplace transform of t to the power n, f of t is equals to negative 1 all to the power n times d to the power n over ds to the power n in bracket f of s. Now, which one is f of s here? F of s, it is something that is multiplying. It is the Laplace transform of something that is multiplying t. So the Laplace transform of what really? The Laplace transform of sine for t. And then the next thing that we need to do, we need to plug the 4 over s squared minus 16 into this equation. So when we plug it, we are going to have negative 1 all squared times d squared over ds squared in bracket 4 over s squared minus 16. The next thing that you need to remember is that we need to first derive the inside and then derive the outside. So what do I mean by that? I'm going to have d over ds in bracket d over ds in bracket 4 over s squared minus 16. So first thing first, we need to derive the inside. How can you derive the inside? We need to remember a particular formula again. Quotient rule. I'm just going to keep reminding you these formulas for a particular reason, because I do not want you to forget them either. So we are going to do that. So again, by deriving that, I'm going to have d over ds in brackets. What's the derivative of 4? It's 0 times s squared minus 16 minus 4. What is the derivative of s squared minus 16? That is just 2s. All of this must be divided by what? By s squared minus 16 all squared. Simplify this. When you simplify this, I am going to have d over ds in bracket negative 8s all over s squared minus 16 all squared. Now you know we need to derive this again using the quotient rule here. How can you do it? To do that, the first thing we need to do, we need to simplify this bracket. So it's going to be s squared minus 16 all squared. What is the simplification of this bracket? It's going to be s to the power 4 minus 32 s squared plus, what is 16 squared? Let me just punch the calculator here. 16 times 16. 256. Like that. So by deriving this once more, what is the derivative of the numerator? The derivative of the numerator is what? It's going to be negative 8 and multiplied with the denominator, which is going to be s squared minus 16 all squared. Plus 8s. What's the derivative of s squared minus 16 all squared? It's going to be 4s cubed minus 64s, like that. All of this must be divided by s squared minus 16 all squared, and then all squared, which is written in red, it is the second derivative all squared. So when you derive this, when you simplify this, you will quite see that there is a highest common factor here, and there is a highest common factor there. So what I'm going to do, negative 8 s squared minus 16 all squared, take out the highest common factor of 4s Lapan. I'm going to have 32s squared in bracket x squared minus 16s divided by s squared minus 16 all to the power 4. Right? Take out the highest common factor of 16x squared minus 16. Let me just cancel this part. Like that, yes. So if you take out the highest common factor, I'm going to have s squared minus 16 in bracket 32s squared minus 8 all divided by x squared minus 16 all to the power 4. So when you simplify this, your final answer should be, where did I miss the sign? But I've missed the sign here. Yeah, there is a mix of sign and there is a mix of multiplication. Can you please check that for me? Yes, there is a mix of sign and then it's going to, but I can fill my answer. It's not supposed to do that. So it's going to be 32s squared minus 8 all divided by s squared minus 16 all cubed. The denominator is right, but the numerator, I do not trust it. All right, so this is the calculation that you need to know, guys. This is what you need to know. And then the last two examples are very common in a major test. The first one, I'm obsessed with it. The Laplace transform of t e to the power 2t cos 3t. I'm obsessed with this one. So the aim is to know that, we need to know this formula. Right? We need to know that formula, standard. And we also need to know the quotient rule. We need to know the quotient rule, which is, d to the power n over ds to the power n in bracket f of s f of g, it is f prime times g minus f times g prime over g squared. Hey, but we need to know this. Now the catch is here. It is that we have three functions. Now we have three functions. How would you use your thing here? It is very easy to do, yes. You can do it in two ways if you like it. You can do it in two ways. I'm going to do it using the multiplication by t because this is the purpose of this video. And the second one, you can just do it using the first shift. You can do it. But if you're using the multiplication by t, we said that everything that is multiplying t, we need to get the Laplace transform of. So we need to find the Laplace transform of this. How can you find the Laplace transform of e to the power 2t cos 3t? To find the Laplace transform of e to the power 2t cos 3t, we first need to find the Laplace transform of cos 3t. What is the Laplace transform of cos 3t? It is s all divided by s plus 9. Because it's supposed to be squared, right? But because we are multiplying this with e, we are going to subtract -2 whenever we subtract s. So I'm going to have s minus 2 all squared plus 9. So it's going to be something like that. And then we are going to take this thing here and sub it to this equation. So now I am going to have what? I'm going to have -1 all to the power 1 d over ds in bracket s minus 4 divided by s squared minus 2 s minus 2 all squared plus 9. Now we need to simplify this denominator. So what is s squared minus, not s squared, sorry, plus 9? It's going to be s squared minus 4s plus 4 plus 9, which is the same thing as s squared minus 4s plus 13. Yeah, so by doing that, I'm going to have -1 times d over ds in bracket. Using the quotient rule to derive this, we need to use this quotient rule here. We first need to derive the numerator, which is going to be 1 times what? Times s minus 2 all squared plus 9 minus s minus 4. What is the derivative of s squared minus 5 plus 13? That is just going to be 2s minus 4. And then all divided by s minus 2 all squared plus 9 squared. Now we need to simplify this, so I'm going to have -1. This derivative must not be here. In bracket, s minus 2 squared plus 9 minus 2 in bracket s minus 4 s minus 2 divided by s minus 2 squared plus 9 all squared. You can simplify this. It is fine. We can do simplify it. It's fine. There's nothing that you need to worry about. But I'll just leave it here as my final answer. So this is the first one. And the second one is the Laplace transform of t squared e to the power 7t cos 6t. Whenever you have three functions and there is an e, and there is an e, try to do some first shift theorem. You will be fine. You understand that? Try to use some first shift theorem. The second thing is that whenever you have three functions and you still have cos, you need to change cos to e's. So this thing is going to be 1 over 2 e to the power 6t plus e to the power negative 6t. So you need to change cos whenever you have three functions. Change cos. So I'm going to have the Laplace transform of t squared e to the power 7t 1 over 2 in bracket e to the power 6t plus e to the power minus 6t. When you simplify this, the half will go outside. I'm going to have t squared e to the power 13t plus t squared e to the power t. And then just use the first shift theorem. Please use the first shift theorem. So what is the Laplace transform? The Laplace transform of t squared. The Laplace transform of t squared is just going to be 2 over s cubed. So your final answer should be 1 over 2 in bracket 2 over s minus 13 cubed plus 2 over s minus 1 squared. And this must be your final answer. Yes, you can do it. You can do this problem using this method here. You can do it. It's still fine, right? But guys, in a nutshell, this is the second theorem. The idea here, I'm just going to write it down. The idea, given the Laplace transform of t to the power n f of t. First thing that you need to do, find the Laplace transform, find the Laplace transform of f of t, and then sub to this. You need to sub to this equation here. Sub to this equation and then get along with this. So guys, I think the video is done. If you have any questions, you can contact me in the comment section. Bye.